Start the session.
So yeah, hello everyone and welcome to day 4 of the APAC Developer Week. I'm Divya. I will be taking the Corda certification prep session. I'm joined by Peter. Peter will be there in the chat. So Peter, do you want to give a brief about how you will be managing the chat and the Q&A?
Yes. Well, I mean, it's welcome back, everybody. It's day 4 already. So I think actually everybody in the chat right now for the past 4 days has been well behaved. So I don't need to actually emphasize the point that we don't want to see any promotional stuff in the chat, and that will get you banned in the chat, in the Zoom chat. So without further ado, if you have any questions regarding the topic, just drop in the chat. I will be there for all of you. Yes, back to you, Divya.
All right, so I will just start sharing my screen. So let's get started. So in this session, we will cover some of the important sections from a Corda certification exam. So this session will help you gain enough information to help you pass the examination. I will try to cover the major components of the examination, but still, you must go through our docs and other references and do some of your own learning at the end of this session. But this session will definitely give you a very strong head start on and a solid base over which you could build upon. So what's the agenda for today? So I will be starting off with Corda Network and Corda Node. Then we will go into the node tree and consensus, an important part of any blockchain network. Then we will look into state, contract, and flow. So state, contract, and flow are the 3 main components of any Corda application, Corda decentralized application. And then finally, I will be talking a bit about oracles. So oracles is another important concept in Corda. So let's get started. So let's start with Corda Network and Corda Node. So this is a pictorial diagram of the Corda Network. So Corda Network, you can think of Corda Network as a fully connected graph where all nodes of the graph are actual Corda nodes. So each node will run the Corda software, and along with the Corda software, it will run the Corda decentralized application called Corda. So you could think of Corda as smart contracts that are there in Ethereum and other blockchain platforms. And also another point to note here is each node represents an individual organization, but typically what they represent is a legal identity. The edges over here represent the potential for the nodes to communicate. So in this example, there's Titan Technology and Bay Transcorp. So this means the potential for communication between these two parties. And all the communication between nodes is point to point and encrypted using transport layer security. This means data is shared only on a need-to-know basis. There's no broadcast that similar to what happens in Bitcoin and Ethereum. And however, if required, I would say that you could broadcast your data to multiple parties even in the Corda network, but broadcast is not the default way through which the Corda network operates. Now there's another important concept called doorman. So the network is permission, the Corda network is permission. So you must have certain authority that will manage your access to the network. So that is done, that access to the network is managed by the network operator called the doorman. And so the doorman will keep check of which parties are allowed to enter the network and which parties will be removed. So this is another important concept, and I'm sure there's a question about it in the certification. And so a node will also have a legal identity. So along with the legal identity, the legal identity will be mapped to the network identity. So a node's legal identity is validated by X509 certificate issued and signed by the doorman. But another important question arises over here is how you as a node identify the other parties or other nodes in the network. So for this, there is a network map service. So you may think of it as an address book where there is a mapping address book which is available to all nodes on the network. And then you could use it to find the parties or the counterparties in the system. So what the network map has, it basically has the mapping of your legal identity with your network identity. So it's the responsibility of the doorman and the network map to maintain this doorman to maintain this network map and update and remove participants from this network map. So the last point to note over here is communication between nodes is peer-to-peer. And it happens via the AMQP protocol, which is Advanced Messaging Queue Protocol. So AMQP is a very popular messaging protocol used in enterprises currently. So I guess people will be aware of it. Moving further, now that we have talked about the network, let's understand the component that makes up the network, the Corda node. So Corda node is a JVM runtime, so which runs the Corda software. Every node has a unique network identity, as we discussed before. And you could think of Corda node basically as a black box, which provides an abstractions for all low-level functionalities. So like it will abstract away all the low-level functionalities like storage, key management, identity service. So to an external developer, the node appears as a whole, and you don't have to go too much into how these services operate. So this diagram is a pictorial representation of the Corda node. The Corda node itself provides two interfaces, the RPC layer and the network layer. So the RPC layer, on the left, there is the RPC layer, and on the right, on the left, there is the RPC layer, which is the remote procedure call layer, and on the right there is the network layer. So all the interaction done by the node operator to the client with the node, done by the node operator or the client with the node will happen via the RPC layer. And so the network layer is used for communication of node with other nodes in the system. So yeah, so as it's a distributed ledger application, the communication must happen with all the multiple nodes that form the network. So this communication happens over the network layer. Another important thing to note over here is you could have multiple applications running on a single node. You could run an insurance application, for example, a trade finance application, and multiple other applications all through the single node. So there is no restrictions of how many code apps you could have on a single, could deploy a single Corda node. So thus to sum up, the node will run the Corda software, and along with it, it could run multiple Corda app applications on that node itself. So when I say code apps, the code app will contain the business logic and the workflows, and that will help you perform transactions on the network. So again, you may think of it as a smart contract in Ethereum. So let's do a quick knowledge check and see if you guys have been listening. So how is information shared in Corda? So the options are on a peer-to-peer basis, on a broadcast, by a broadcast to the network, on a gossip protocol, and none of the above. Obviously, as I mentioned before, it's on a peer-to-peer basis, and there is a point-to-point communication between nodes, and the entire messaging is encrypted. So now moving further, the next section will be, let's move over to node tree and consensus. So like all distributed, in any distributed ledger network, there must be a consensus on the ledger data or on the ledger state. So all the blockchains deploy some kind of consensus algorithm. There's proof of work, there's proof of, PBFT, there is Raft, and multiple other algorithms. Similarly, Corda requires a consensus mechanism, but the consensus in Corda is a little different than what is there in other blockchain platforms. So in Corda, the consensus basically happens at two different levels, the validity consensus and a uniqueness consensus. All the transactions in the network must pass through both these consensus levels before they get approved and updated to the ledger. So what is validity consensus? So validity consensus basically refers to the checking if the content of the transaction is valid and whether you as a node approve of that content. So this validation is performed by the signers of that transaction. For example, there is party A and there's party B. Party A proposes for an agreement transactions with party B. So in this case, the party B must validate the transaction, the content of the agreement, in turn the content of the transaction before it approves of it and signs the transaction. So this is validity consensus, and it is being performed by this is being performed by party B in this scenario. Then there's uniqueness consensus. So uniqueness consensus basically refers to the check of double spending that is done by notary. So the notary verifies that the transaction doesn't consume any historic input state, or in blockchain terms, you call that as double spend. So you see that none of the input states to transactions have already been consumed in the past. So in that case, the transaction is discarded by the notary and disapproved by the notary. So thus, the consensus basically checks for validity and checks for uniqueness, and ultimately it maintains the integrity of the ledger so that you have that trust in the data, data fields and the transactions that appear. So to summarize, the primary purpose of the notary is to prevent double spending via the uniqueness consensus. So a notary can either be a single node or it could be a pool of nodes called the notary cluster. And this notary cluster could either run a raft or a BFT based algorithm, a consensus algorithm, as it's a permission chain. So now notaries come in two flavors. So either you could have validating notaries or you could have non-validating notaries. So what exactly is a validating notary and a non-validating notary? So a non-validating notary will not check for the content of the transaction. So it will only check if there's a double spending or not. It will only see if the input state references are unconsumed and have not been and are not historic. But on the other hand, you have the validating notary, which will see the entire contents of the transaction and will check for the business rules. So thus, each one of the notaries has its own benefits and drawbacks. When with a non-validating notary, you only check for double spending, but you don't validate the contents of the transaction. So while in case of validating notary, you validate the transactions, but you expose the data of the content of the transaction to the notary. So the decision between a validating and non-validating notary will be more or less driven by the use case or by the requirements of your specific application. So I won't go too much into the details of what these two are, but Peter will be posting the link that will explain you further about these two concepts in the chat. Another point to note over here is you could either have a single notary node in your network, or you could have a notary cluster. So what is a notary cluster? Notary cluster is like a group of notary nodes that have come together and they run a consensus algorithm amongst them. So notary is again a very important concept in component for our certification examination. So let's test your knowledge. So the question is, which parts of a transaction does a non-validating notary see when signing a transaction? The options are the input state references, the time windows, and the transactions notary. Only the input state references. C, the input state references and the time window. And fourth, the input state references and the transactions notary. Take your time to think through the options, but just for the sake of time, I will go ahead and give you the answer. So the answer to this question is A. So the input state references are obviously required to check for the double spending. The time window will again be required. So what's the time window? In some cases, you may want your transactions to only pass through in a specified time interval. So in that case, notary will then verify if the current time of the transaction falls within its time window specified in the transaction. So there it becomes essential for the non-validating notary to know the time window. So thus it's a mandatory information that the non-validating notary will see. And lastly, there's a transaction notary, because notary must check if it is indeed specified notary for the transaction or not. So if it's the specified notary, then it could either approve the transaction. So otherwise, if it's not the notary in the transaction, it will have to disapprove of it. All right. So let's move to the third section, which is the states, contracts, and flow. As you all know, these are the three main components of a code app. As a developer, you must code all these three important components in your application. So a quick reminder, what is a code app? A code app is a Corda decentralized application. You could think of it as a smart contract for the Corda network, and it contains your business logic. It contains the business logic of your application. So a code app consists of the foundational components, state, contract, and flow. These are the main components that the developers code. States are objects in Coda, and they represents the data that you want to add to the ledger. So for example, they could represent an asset or a token you issue on the ledger. So they will contain all the properties that and attributes that you want your asset to have or your token to have. So these states can get consumed. So these states can get consumed or updated or stored. So in turn, you are defining an object on the ledger, and then you are either consuming that state object, or you are updating it, or you are storing it, just storing it there. Now, the contracts. So the contracts contain the business rule that needs to validate during the update and consumption of the state. So they are the rules which validate the evolution of your state. So let's say if you have defined an asset in the first step, you have defined a state. So the contracts will govern how you would like that state to proceed, and what are the validations you would want to be performed during the update of that state. So contracts verify the transactions that want to modify the state objects. Thus, every state must be tagged with contract rules, with the contract rules of the contracts, and are verified before the transaction is passed through. A transaction is only passed through only when all the rules from your contract are satisfied. So even if there's a violation of a single rule, the contract won't be approved, the contract won't be checked, and in that case, your transaction for the updation of the state object will fail. Lastly, we have the flows. So flows, what flows do is flows define your business workflow. So in real world, for every transaction that we do, there are certain workflows that we follow. There are sequential steps that we follow. So your flows will define and contain these workflows. For example, while doing a transaction, you could do operations such as calculation, or verification, or signing and data writing. So all these steps will get executed in your flow. And so the flow will see if like how you create a transactions, how many signatures you require, and then how do you want to distribute the transaction, which notary do you want to use in your transaction. So this is just a high level overview of what you could do in a flow, but we will go into much details in the later section. So in conclusion, in any code app, you need to build all these three components. Well, the state and the contracts go together in the same jar, and the workflows go in a separate jar. This is because the contract that you define applies to the asset, and it's the same for the entire network. So all the parties of the network and the code app will have the same contract class or contract file. So if there is any transactions that happens on that asset, the business rules will be the same for all the parties. However, the flows could be different for each organization, because each organization may choose to have a totally different business workflow. So that's a very high level of what are the components of a code app. We will see into the state object now. So moving on, we will look at each of these components: state, flow, and the contract. So moving on to the Coda state. So all Coda states must implement the interface, which is the contract state interface. It appears as red on the top. So the contract state becomes the base interface for all your states that you define. There could be different types of states. There are APIs, classes, and interfaces that you could use that would help you with the creation of these various types of states. There's linear state, there's fungible, there's ownable, there's queryable, and there's schedulable. So I will explain in simple terms where each of them would be used, because for the certification examination, it will help if you know what exactly the states are and where they are used. So starting off with linear state. So the linear state is used to represent a state object which will get linearly updated. For example, you have a house. So in case of a house, you have this state object, you have that state object on the ledger, and it has to move linearly. So in every transaction, it has to go as a whole. It will go as a whole and it will get updated. You can't have a transaction where you say that, okay, half of the house will go in as an input to the transactions. So that means it cannot be split and merged. So that is linear state. So this is where you will use linear state, and you will have your house defined as a linear state object. So on a totally other hand, there's fungible state, which would be used to represent assets that are fungible. So basically what fungible means is they could be split and merged. So for example, it's cash or stocks. So what you could do is, you could, in a transaction, you could have 100 stocks, and out of which you sell 50 of them. So in that case, you are splitting the 100 stock units. So there you could use fungible state. The third one is the ownable state. So these states are used to define or model assets which are supposed to be owned by the single identity at any point of time. So let's say you have a particular owner of an asset. So in that case, owner of the asset that you define initially, and you want that owner to change over time. In that case, you will have an ownable state. You will use the ownable state state class to define that state object. So there are more helper interfaces. There's queryable state and schedulable state. So queryable state, in general, what happens is your state data is stored in your database. In the database, or in your nodes vault in a binary format. But there could be instances where you want to create your own personal schema, customized schemas, and each of the fields of the state you want to go in there as a schema. So this could be required for various purposes. This could be required for your internal auditing, or some internal integration. So in that case, you may want your state objects to be stored in the vault in a custom schema. So there you will be using queryable state interface to define your state object. And lastly, you have the schedulable state. So to keep it brief, there could be instances when you would want to schedule a particular event. So let's say you want to schedule a particular transactions in a future. So in that case, particular transaction in the future, or at a particular time in the future. So in that case, you would use the schedulable state. So there's one more point worth discussing over here is reference states. So many a times what happens is, in a transaction, you just have to refer to another state object in your transaction. So you don't want to consume that transaction, you just want to use that as a reference and in your transaction, so that the other parties could verify that reference state and then approve your transactions. So in that case, you could add that state object as a reference state, but that reference state object won't be consumed in these transactions. It will just act as a reference. So this sums up the major important state classes and interfaces that you would use. So there's linear state. To summarize again, there's linear state, there's fungible, ownable, queryable state, and schedulable state. So let's test your knowledge. What field does the Corda contract state interface define? So you define the contract state interface. So what field does the Corda contract state interface define? So the options are, there's contract, there's legal pros reference, there are participants, and fourthly, there is owner. So the correct answer over here is participants. So because when you define a contract state, you don't define the contract information as a field in your state. So what you define is, you use a particular annotation called as belongs to contract to define the contract for your state. The legal pros reference. So legal pros reference is again that is not again something that is not mandatory. You could choose to have it or you could choose not to have it. Participants, so participant becomes mandatory because that is how it is determined to whom the state is shared with, because at the time of declaration you could define which participants should be alerted of the creation or updation of that state. So participants becomes the mandatory field. And owner is again not mandatory. You will have that in an ownable state, but in general cases it is not required. So let's look at contracts now. So we have been talking a lot about transactions. So what basically is a transaction? So a transaction could be simply viewed as an update to the ledger. So it's a proposal for an update to the ledger. You take in an input state and you produce an output. So you take in an input state, you produce an output, and you propose that change in the state object. So in that process, you execute certain flows and you validate your contract. So for any transaction, what you do is you fetch the input state from your vault. Obviously, the state has to be unconsumed because Corda uses a UTXO model, and if it's a consumed state, obviously your transaction will fail. So firstly, what you do is you query an input state from the vault, and then you propose the input state with the desired output. So then you will propose the desired output state data. So through this, you define the updates. Ultimately, through this, you are defining the updates that you want to make on the ledger. And all this happens inside the flow. So you trigger a flow with the input state and the desired output state. You send it across to all relevant parties in the network. The parties then verify if the proposed transaction fits into the business rules they have defined in that contract. And once everything is verified and everything is checked, so they could then either sign or reject the transaction. A transaction goes through only all the required signing goes through only when all the required signing parties have approved of it. So once you have proposed the transaction will go through all the parties. The parties will all check for the contract rules, and if they approve of it, they will sign it. And once all signatures are verified, and then only it could further move to the notary. And ultimately, if the notary checks for double spending and if it approves, then the transaction will be updated on the ledger. So what I mean by updated on the ledger, so this means that like it is recorded in the vault. So every node has a vault that they maintain. So recording the vault means that each party, the vault will have the input state as consumed and the output state as unconsumed. In other words, the state data will get updated with the parties. So all the state data and the information that you have proposed in the transaction will get updated with the parties and in their nodes vault. So yeah, a fifth certain points to note over here is contract code is deployed on every node of the business network which uses the code app. So everyone will check the transaction with their contract code. The contract assures the validity of the transaction and thus governs the evolution. So basically, if you have got any bug in your contract, then there could be problems with your entire application and business logic. So the contract becomes a very important part or a very security intrinsic feature that you must take care of. And so the transactions are verified by both. The transactions are verified firstly by the initiator who has initiated the transactions, and then it is again verified by the responder. One another point to note here is that we also have something called as commands. So if you look into the diagram there, you see two transactions happening. One is the registration, then the other is the service. So the registration and service, they basically represent the commands for that transaction. So what are commands? So basically they represent the intent of the transaction. So in this case, in the first transaction, registration is your intent for that transaction, and in the second case, service is the intent in that transaction. So depending on these commands, you could define different rules in your contract. You could define what are the checks you want to perform during registration and what are the other checks you want to perform during service. Now commands will again contain the signers. So we have been talking about transactions, about the transactions, about that transactions and how they must be signed. So the signer details are mentioned in your command, and there should be always be one or more signer, because obviously even if it's an issuance transaction, there has to be a single signer who has approved of it. Otherwise, with no signers, the overall command data doesn't make too much sense, or the transaction doesn't make too much sense. So let's move forward. How is contract code? Let's take a question. How is contract code represented in a Corda transaction? It's a contract jar file is attached. The contract jar file is attached to the transaction. Option A. Option B, Corda transaction does not contain any information of the contract. Option C, the contract's jar hash are attached in the transaction. Jar's hash is attached in the transaction. And D, none of the above. So, the correct answer here is answer C, because you don't need to attach the entire contract jar hash with the transaction. All you could do is you could just attach the hash of your contract jars to the transaction, because ultimately all parties that need to sign the network have that contract jar with them. So even if you pass the hash to the transaction, they would be able to pull it out from their vaults, pull it out from their code app, and then verify for the content of the transaction. So the correct option here is option C, because you don't need to attach the entire contract jar in the transaction. You could just do away with attaching the hash of the contract jar. So let's move on to the next section, which is flows. So as I mentioned before, so flows are the components that help you model your business workflows. So you basically propose a transaction and you define the steps that you want to happen in that transaction through the flow. So the flow helps you interact with other parties and model how you want the transaction to happen. So let's take an example of a single two parties flow. There are two parties, there's node A and there's node B. So let's say node A wants to propose a transaction to node B. So what it will do is it will propose an update. It will check for the update. So when I say check for the update, it means it will check for the update with its contract, and then if it approves of the update, then it will sign the update and it will send the transaction to node B. So as you see, there is a send object and there's update plus one signature, because the transaction has only got one signature from node A. Now at the node B's level, the node B will check for the update again, and it will sign the update if it approves of it. So now your transaction has two signatures. We'll go back to node A. So the node A then sends the transaction to the node tree for the final timestamping and the final approval. So the node tree will check for the double spending and other details, and if it approves, it will update the transaction. And finally, your transaction will have three signatures: signature of node A, node B, and the node tree. And once it is reverted back to node A, the node A will record that update saying, because the transaction is now committed, once it has been approved by the node tree pool or the node tree, then it is approved and it is finally become a valid transaction on the network. So in that case, node A will record that update, and similarly, it will forward it to node B, which will again record that update. And that will be the end of the entire flow. So all these processes, all these steps define your business flow, and they all go within the flow section of your Corda. So to sum up again, the state is where you define the object or the entity that you want to issue on the ledger. The contract is where you define the business rules that must be validated for in your core tab. So the validation that each node wants to perform in their transactions, that goes into the contract. And the flow section defines the workflows or the business flow that you want your code app to have. So it's basically how you want the transactions to be proposed and the steps you want to happen, steps you want to define and signatures you want to take. So quick points to note here is flows basically automate the process of agreeing ledger updates. So when in the last example we saw how the node A sent the transaction to node B, and both their signatures were taken, which and that was ultimately concluded by the signature of the notary. So this entire steps go into the flow. So flows automate the process of agreeing the ledger updates. Firstly, the simple sequence is obviously you build a transaction, you verify the transaction, and you sign it. So once all signatures are taken, when the notary approves of the transaction, then you record it in your vaults, and that's the end of the flow. So yeah, as you saw in the next last example, the node A initiated the transaction, and the node B was again responding to that flow. So thus the flows always come in pair. There's one initiator flow and the one responder flow. So initiator flow will be initiating the transaction, and responder flow will be listening to the initiator flow and responding accordingly. And lastly, an important point to note here is flows guarantee eventual finality. So flows ultimately guarantee eventual finality. What it means is, if your flow has run successfully, and if your flow has gone successfully through all the steps, through the notary, through other parties and signatures, then it is guaranteed that your transaction is settled and recorded. There could not be the case where your transaction even after going through all the steps of the flow, the transaction was not recorded. So the flow will ultimately reach the eventual finality, and ultimately you will have your transaction. If the flow was successful, your transaction recorded into your vault and the database of all the relevant parties. So let's test your knowledge again. We have another question. What annotation does a flow need to be triggered from an RPC call? So while you are defining a flow, there is an annotation that you use to define whether the flow could be triggered via RPC or not. So what is the annotation that you use to define whether you want your flow to be initiated via RPC? So the options are: there's counterparty flow, there's starting flow, third is startable by RPC, and fourth is responder flow. I will give a couple of seconds for you guys to think. So the correct answer here is C, startable by RPC, because obviously the annotation itself, it's self-explanatory. If you want your flow to be allowed to be triggered by RPC, you could use the annotation startable by RPC. So the responder flow is only used when you are responding to an initiator flow. So it's not an annotation. Only startable by RPC is an annotation that you use. So we are almost at the final section. We have seen about Corda Network, we have seen about Corda Nodes, we saw about notary consensus, and finally we saw about states, contracts, and flows. So ultimately it's time to look about oracles. So we will just take a quick overview of oracles because it's an important topic in our certification examination. So what is an oracle? So Oracle. So we often think of blockchain as a closed system. So we often think of blockchain as a closed system where the data on the ledger is generated within the system, and it is approved, validated by the parties of the network and parties of the network. So thus the entire focus of any blockchain is, or of any blockchain, or the focus of the entire DLT technology is about trusting the data that is there on the ledger. So we know for sure that the data on the ledger was generated internally, it was varied and approved by the parties, and only then we trust that data. But there could be scenarios where you would want your Corda business logic to perform operations based on data from external sources. So, for example, in your Corda, in your Corda, you may need external information such as forex rates or share price. So, and so there you have an external information. There you want an external information to be included in your transaction. But then the question arises is, how do you bring some external data to the ledger, and how could you have the network trust this information? Because ultimately, if it's an external data, then you don't have that trust with that data. The network doesn't have that trust with the data. So this could be done using oracles. So why do we need oracles? So the contract code is something that is something that cannot be dependent on the non-deterministic information source. Since when you propose a transaction, all parties must validate and verify the transaction, and they must come to an identical conclusion. So they must come to a final state or final state object. So if you have any contract update or transaction update happening, so you can't have a non-deterministic result scenarios. So but when you have, like, the thing is, when you have an external information injected to the network, you add that element of non-determinism in the contract. So firstly, you can't have, your contract has to be deterministic, and when you add some external information, you add that element of non-determinism in the transaction on the network. So in that case, it becomes important that you have some party that approves of that external information. So so that role is taken by oracle. So an oracle is a trusted third party information source which provides off ledger data to the blockchain network. Any node so as a node, you can just contact the oracle and get some off ledger data. So once the node has the data from the oracle, it could include it in the transaction, and have this transaction signed by the oracle. So this signature by the oracle, this provides the trust to that external data. And once that oracle has signed, only then the other parties will have a look at the transaction, and seeing the signature by the oracle, they will then approve of it. So basically, oracle acts as a trusted third party informational source which provides authenticity to your external data, and based on the oracle signature, the other parties of the network will approve of the transaction. So let's take a look at the simple flow involving an oracle. So as I said before, the initiator or the party who wants to add an external information will initiate a flow requesting data from the oracle. So it will initiate a flow and it will query oracle. So it will query for the oracle data. So the oracle service, oracle is a service. So the oracle service will query oracle data, and it will fetch data from the service, and then it will send it back to the initiator party. So based on this data, the initiator party will build and sign your transaction. Again, it will fetch, again, the initiator party will fetch signature from the oracle. So the oracle will then verify the transaction and see for the components, that is like the components, the data that they had, it has initially sent. So once it approves of it, once the timestamping and other considerations are taken care of, then the oracle could either approve the transaction or validate the transaction and then provide the signature. Once the oracle has given its signature to that transaction, the transaction could then go back to the initiator flow. So the initiator will then request other parties to sign on the transaction. So note that the transaction now has the signature of the initiator party, and it also has the signature of the oracle. So based on this signature, the other party will approve of that non-deterministic external data that was added to the transaction. And once the other parties have checked for the oracle signatures and they approve for the transaction, then only they would sign and validate the transaction. So and ultimately, once they have validated, then the entire flow, the similar flow will continue. So where the other parties sign the transaction, then the transaction moves to the notary. The notary again checks for the validity and double spending, and ultimately, if it could either be approved or rejected. So this is the entire flow that happens in case of an oracle. In case you have an oracle service included in your transaction. So I think I'm pretty much done with this session. We have seen about Corda nodes. We have talked about the network, about consensus, node trees, and the oracles. I think this covers almost 60 to 70% of our certification examination. But still, I would suggest you guys to go over to our GitHub samples, have a look at the code bases, and then build your own code application, build your own simple code application, because that will help you answer the code related questions that are there in our examination. So that's it. So Peter, how are we doing the chat? Do we have any questions?
We have actually quite a lot of questions. So actually with actually one one person in the audience, Ravi, are you there? So if you want to come to the stage and we can discuss the one question. So we are a little bit running over in the sessions, but I do want.
We're good, Peter. If I would rather spend the time on the question. So if Ravi can just raise his hand, and then I'll bring him up so you guys can chat with him.
Yeah.
So yes, his talking is permitted. So Ravi, you can go ahead.
Yeah. Thanks, Ravi. So actually, let me go back to the question that you were asking previously, the network one. Can you elaborate a little bit on the network one, and then I will get to the one that you just asked. I will take over.
Sure, Peter. Can you hear me?
Yes, we can.
Okay. So let's say I am an organization, a technology organization. Okay, I am setting up a blockchain network, or setting up a network using Corda, because I want it to be a permissioned network. Okay. So my goal is basically, let's say, to provide a network for some hospitals. Okay. To interact with each other or perform some transactions. So as part of that, my organization, which is an independent software company, sets up this ecosystem, right? And as part of this ecosystem, so I make the hospitals who are my customers as in nodes in the network. Hospital A is a node, hospital B is a node, hospital C is a node, and so on. So now they transact with each other, okay, I'll say through code apps and all that, right? All the states, all the state transaction workflow, all that we discussed. So where is the ledger actually stored? It's actually, ledger is nothing but a vault, isn't it? Right. So, and what is that technically? So technically it could be H2, which comes by default, or it could be an RDBMS section that I can provision, could be a SQL Server, MySQL. And how do I log into MySQL, either manually, or how do my node talk to that one is to the credentials, right? So my software node, Corda node, talks to that using a MySQL connection, right? So I, as a software independent company, will have access to the credentials because I have set up the entire node infrastructure, right? In a virtual machine or a collection of virtual machines, I set up the node complete network. So I can log in and I can see the transactions. I'm not saying I'm not authorized. Let's say I am authorized person because I have set up, let's say I've got a non-disclosure thing from all the hospitals. So for me to maintain this entire network, that's why I have the credentials. So this means that I can go and see the ledger of each and every hospital. Is that right? In the database.
Okay, so yeah, so let me actually rephrase the question. So you working for a technology company, so I mean, whatever that is, you have connections to, you have the abilities to run a network among different hospitals, and then you can set up the node for all of them, and then you are planning to run that system of DLT network. Is that correct?
Right.
Okay.
It's a net.
Yeah. Okay. So let me actually ask you the very first question. So what's make it difference that you can do it on a centralized database system?
Pardon? Could you repeat? Okay.
Okay,
Okay.
so
What can be done with the centralized database system, right?
Yeah.
So there are various reasons, like immutability is one of them, because in the centralized database system, and then and as part of here, it's all every new transaction will have a hash of the previous transaction in Corda. So even if I tamper with some data, I will not be able to. I mean, I can easily say something got wrong or it's not right. So it provides that additional benefit. It's one of them. Am I right?
Yeah. So okay, so that's a very good point to begin with. So let me say this. So even though I work for this company, R3, right? You know, we are enterprise blockchain companies, but we like to, before working our clients or actually talk our client into using Corda, we need to ask a couple questions. The first question is I just ask you, why can't you use a centralized database? And you actually answered it very well, because you like the immutabilities of the DLT network. So the second question is why would you have to choose a private network instead of a public network? Again, well, even though I work here, you know, we want to bring value to our customers. So the question is, why can't you use a broadcast model, a public blockchain to build it?
Got it. So the reason why I want to do with this permission private ecosystem is for sake of privacy and security. Those are the two primary reasons. And especially what I like in this one is the need to know basis, right? So I don't want the data to be available in a centralized vault, a centralized database where everyone can see it, right? So here only, let's say hospital A can see only its data, hospital B can see only its data, where it's involved in, where the facts are shared, only that's it. So it gives the, on an overall, for each and every of the parties or nodes or hospitals, they are entitled to see the data only they want. So which is not available that easily in a centralized database system. Right? That's when this decentralized thing, there's an advantage. Every node has its own database, right?
Okay, cool. Good. So now we're talking. So now you actually realize, yes, we need to do this in a private way, and we want to benefit the immutabilities. So now actually back to your question. So you are keep asking that how we can see the ledger from other node. That's the part I don't get it. So can you actually elaborate a little bit more?
Okay, great. So while the privacy and security is maintained across all the nodes, there is no doubt in it. It's clear, right? It's clear. So because I maintain all the nodes in the network with an approval from each and every organization who is part of this entire ecosystem, so I have provision to see the data. Is it right?
So if that's the case, yes. As long as you can log into the node, and in your case, I guess, yes, because you set up all the nodes. So sure, yeah, you can look into the data of every node because you set it up. It's your node. Yeah.
Correct. Absolutely. Absolutely right. Yeah, that's what I wanted. I mean, it's not any concern because I'm authorized person. I'm seeing it. There is no concern at all. It's just for me to get clarification. I asked that question. That's it.
Okay.
The parties in the network have trusted you with the operation of that node. So in that case, ultimately, you will be able to see the data, and they're trusting that private information.
Absolutely fine. So I have a follow-up question. May I ask?
Yeah. Yes.
So okay, now let's say this is answered, it's clear. Okay, there is no doubt in it. So now as a one node, let's say hospital A has got various people in it. There could be hospital, could be doctors, and there could be patients, and some other staff in the hospital, right? So all of them are kind of users, right? You can just say them as users, and they'll have different privileges based upon what their role is. So if I want to onboard them to their node, okay, so how do I onboard them to their node? Should I go with a token concept which we discussed? Sorry, not token. User account concept which we discussed yesterday, or let's say, I need to maintain my own identity management service, like for example, AWS, Cognito, or Microsoft Azure, those kind of things. How should I invite them? Because doctors needs to be invited.
Were you here yesterday?
Live session. This is the first day.
No,
I watch each and every recording each and every day.
Yeah, I know. I'm just messing with you. So yesterday I had a session talking about token SDK and the account SDK.
Yeah,
so
that's why I seen the video. Yeah.
Yeah, account SDK basically brings up multi-tenancies of the node. Because all those doctors, patients, or whatever employees, they are not really, how would I say, they are less important on the network level. On the network, we only care about hospitals. We care about, whatever medical regulators in India or in your region, whatever. So those are the important entities that we want to focus on the network. For the doctors, patients, they are end users. If they give you the consent to basically onboard them into a DLT and they don't care about their data is being shared with the hospital, yes, you can use Corda account. You can have 1 million patients, 1,000 doctors, all in the same node, same hospital.
Awesome.
Depending on what legal identity you want on the network, you could have a single node and have the multiple accounts of your doctors with that linked with that node. So you don't have to go with the setup of having separate node for each doctors.
Right. And with this user accounts in place, so I don't need to maintain any third-party identity service such as example, Azure Active Directory or AWS Cognito kind of thing. I don't need to maintain, right? I can just rely on the Corda.
Yeah, so the Corda account is entirely a Corda level 2 applications. Basically means level 2 means it's not in the platform, it's the add-ons. So network, you as a developers, you can choose to use that feature or not use that feature. So it's your choice. So that's what we call level 2 application on the platform. So that means all the development, all of the functionalities are in the core app that you are developing. And you can basically maintain an ecosystem like right there. What you're talking about, all those OAs, authentications, you can use Google OAs or AWS OAs, that happens off the ledger. So it's like when they're on the website, they try to log in. If you want them to go through OAs, Firebase, Google OAs, whatever, that's your off-chain web application. So you take care of that there, and then all of the accounts are entirely Corda based. So it's separate. Yeah.
So they're separate, and it's my responsibility to link them. Is it right?
Sorry, what?
And it's my responsibility to link them, right? Because when I use
you gotta link them, because at the end of the day, people need to log in. How are they gonna log in? Right? They need to have an application they can log in. You can do all of your authentications on the applications. So yeah.
Got it. Thank you.
Okay. All right. Thanks, Ravi. And I think that's our QA time. Back to you, Divya.
Yeah. I think we have overshooted with the defined time and time period. So I will conclude. Back to you, Naveen.
Oh, that was awesome, Divya. Okay, so I got some confidence to give the exam now. So those are some amazing questions. I was not able to answer all, but yeah. Great. Okay, great. So I hope Divya, you enjoyed that session.
Yeah.
Oh, great. Thank you so much, Divya. Let's move towards the break now.